Hi guys, you're welcome back to my channel. My name is Promise Ekeh, and on this channel we talk about data science, machine learning, artificial intelligence and other technological advancements. If this is your first time seeing me, click on the subscribe button to be part of this community. In my previous videos, I've talked about we've been going through Code April series. I told you it was going to be a 6-part series, and this will be the 5th of 6-part series. I've walked you through the Code April week 1 to week 4. In this, I will be attempting one of the projects. So this, I will be going through the airline data set. So if you participated in Code April and this was a project you chose, work with me and let's see how I would attempt this project. The data set we'll be using will be the cargo data set, the airline data set. So I sent you the link, but I'll put the link in the notebook so you can always go search. I think I've opened the link before. So this is the data description about the data set, and I'll be downloading the version 2, the latest update one, and this just identifies the columns, the passenger IDs and things like that. So we have about 98,000 passengers. Okay, so let's just take this out and read. So we read the data, so you use the dot head to see the first 5 rows in the data. So we have our passengers ID, first name, last name, gender, age, nationality, and things like that. So the next we're just going to check. So when you start the data analysis, the first thing you want to do is you want to check for the information about the data. I just want to see what you have in the data, the rows, how many columns, things like that. So with our data info, it shows us that, okay, so I think the data is pretty much a clean data set, so we don't have any missing data. So data info, first name, so the data is pretty much a clean data set. Then we do our data describe. So from this, so with this info, you also want to check what data type do you have within the data. So we have our age is our only integer value. The others are objects, so we may have to look at that to see why we have that. So from the header, you see that they are mostly categorical values. So we have age and our departure date. It should be in daytime, but we can always convert that during the process of interpretation. So if you do describe, it just pulls out only the numeric column, and this we have the mean. So the mean age is about 45.5, and we have our maximum age as 90, minimum as 1. So we have range from 1 to 90-year-old within our data set. Okay, so the data.isNet.sum just shows you if you have missing data in your within your data set. So I think I mentioned earlier that data set is a clean data set. Data.column just shows you the name of all the columns you have within your data set. Then if you want to check the average age, so I think we've seen it before, but you could just print the age column domain just gives you an average. So you want to also do value. You want to check, okay, I have gender, how many male, how many female. So you could use those value to count on the columns to show. So we have about it's just about the same amount of about 500 different more males than females. So you could plot this using a pie chart. So this is just shows you, like I said, a picture says more than 1,000, rather than just saying it. It makes more sense if you do visually. So if you plot or do a pie chart, you see the distribution. So they're about the same thing, just the males slightly more than the females. Also, we could do the same thing for the nationality. So before you do this, we might want to check. So so let's just run everything up there. So I want to check. So before you do the nationality, I want to say how many unique nationalities do I have. I can do unique and unique. This would give me the unique nationalities. Let's just wait for this to run. Okay, our data set is still running. Okay, that's fine. So before you want to see what's the unique nationality do I have. So they have a lot of nationality within the data set. But if you use the n unique, it will give you how many unique nationalities you have. So I will do n unique. So it shows you we have about 240 unique nationalities. So this is the value. So the highest within the data set is China. So the Chinese travel more, like we have more Chinese within the data set. So now let's start going into transformation. So most times when you do analysis, it's good to normalize your column headers, like eliminate things like space. That's what I have done here. So remove remove the space from I replaced it with the underscore and also changed it to lower. I think that's just this will have a normalized data set, so you're not sure so that you are not confused. Oh, does this column is it space, or is it not space, or is it capital letter? So it's just good to have them as good underscore normalized. And the next thing we wanted to do was to change convert our departure date. So remember when we checked it initially, our dates. So if we do airline departure date, let's see departure date. What do we have here? Dot let's see D type is string, so it's showing this. It shows that it's string. And okay, so we need to convert to date time. So if you follow the resources, I think from one of the days we showed you how to convert from date to time, from strings to date time. So first of all, we want to replace. So let's run this. Okay, so in some cases you want to replace, so if we look at the data set, in some cases we have it as slanted, in some cases we have it as hyphen. So normalize, so just replace all the hyphen to backslashes, and you convert data. So if we do this again, so let's just do this again here, you see that date time. Did we run this? By the time we run this, it has been changed to date time. So you can apply date time analysis to your data set. So let's see. So now we have everything as date time. Departure date will be in date time. So you could use it. You can get the month, get the day from your data set, but we'll do all that later. So I also want to check, before we do that, so we have our age. I wanted to just categorize, rather than having age, you want to categorize children, teens, adults. So you could just write this F screen. This is not compulsory. I just thought to do that. Categorize your age. So if your screen, if it's empty, it's none. So if this age is less than 10, you want to call all children less than 10. Between 10 and 18, they are we call them teen. Then above 18, let's make it 19 to 45. They're adults and elders. So this is just a small function. So I created a new column called age group. So just so I still have my age, but I have my age group as the different people. Then you could do the distribution of. So let's just try something. Let's do not this. Okay, let's do airline age group. We do this, you see we have more elders, that's people are above 45, as 49 okay, about 49,000, half of the data set. Then we have adults, we have children, we have teens. Okay, you can also choose to do like a pie chart to see the distribution of the different age groups you have. Let's see, not data now, so let's make this airline. Let's just get this as airline. Okay, so we have about half, 50% are elders has greater than 45, and we have adult, then we have children and teens. Okay, so now let's start more data visualization. First of all, I want to check how many unique items do I have in each of my columns. So you could use this for loop to check what are the different. So for example, passenger, we have about 89,000, approximately 89 or 99,000 passengers. Just gives you different things. So first of all, I want to see, we have flight status. The main thing, we have the column that shows you if a flight was delayed or cancelled. It shows you, okay, it is evenly distributed. So we have approximately the same number of cancelled flight, on-time flight, and flight that were delayed, about 30% of each of them. So I want to do the distribution of age. So we have good distribution. Okay, so the next thing I wanted to view is I wanted to see the distribution of the different ages based on the cancelled flights. I want to see, for example, adult, how many flights were cancelled for adult, things like that. So I just wrote this code. So group the data by the age and the age group and the flight, and you can break down this to see what they all do. Like for example, let's take this. Let's take like I said, if you see a code and you're confused, try to take it apart and see what it does. So this part just gives us the data. So for example, I have cancel, delay for the different age group, then I plot. So I can plot different variables, different things. So like I said, with Python, one of the good thing about one goal for Python is to make your code reusable. So rather than doing the same thing over and over again, you want to automate. Because of that, I created a function to plot group bar. So if I call, anytime I call this function plot group bar, it plots. All I need to give it is, so I give it the data I want, the S column and the column I need for my legend. So the same thing I have here. So the legend is flight status, the column is age group. Okay, so I also did plot. So if you want to plot, just want to plot bar charts without grouping, you can use this. Okay, so for example, let's see, let me run this function and run this. So these are just two functions to plot. So if I want to, you see where I'll call plot bar or plot group bar. So in this place, I called my function plot. I want to plot the age. So the same thing I've done here, just wanted to replicate it here. In this case, I have it as this. In this case, I wanted to reverse the same thing. So the same thing, but seeing it in a different way. So that my flight status would be my x-axis and the age would be the thing. So if, for example, you want to see cancelled, we have more elders cancelled, because generally you see that they are more in the data set. So you attempt to see that. So the next thing I wanted to see is the continent and gender. So just wanted to say, okay, for example, generally we have more males than female, like we said, but for Africa we have more females traveling than the male, and the same with Oceania. So in this case, I'm plotting the top. Yeah, so just group them by that to see the different regions. Okay, yeah. So the continents. Okay. Then I also wanted to see, in some cases, you wanted to, because we have, for example, we have 240 nationalities, and I wouldn't want to visualize the 240 nationalities. I just wanted to visualize, let's say, the top 20. So I just used this to get out so group by the nationality and gender, and I got the top 20. So you see that we have Brazil. So it's the data set is pretty much more clean and sorted. So you don't really have differences, but you can just easily see how they are different. And you could choose to plot top 10 countries. So in this case, we're just plotting bars. In these places, we're plotting group bars. So you want to see how things variables compare with different columns and different attributes. In this case, we plot them bar, just plot only the bar charts you want. Okay, so I just plot top 10 to see. So we have more China, followed by Indonesia, Russia, and the 10th largest country within the data set is the United States. Okay, so this is nationality. So the good thing about function is I don't have to do the same thing over and over again. So by just calling this function, rather than always repeating those 4 lines of code, I have my chart plotted for me. In this case, I wanted to plot the airport name, so the 10 largest airports. I can see, so the not largest airport now, the most departure from airport name. So for example, we see San Pedro Airport had the highest departure count, over 40. You have, so that's what that will show. Then okay, so in these cases, we've been plotting the top 10. So I wanted to combine rather than always having to call this top 10. So you could just include it in the function. So in this case, I said, okay, I want to plot top group bar, plot top group bar. So in this case, I have my columns as argument, like the data as argument, the S column, the legend I want to use. And in this case, I included. So if you look at the group bar before, I didn't have what I called size. But in this case, I have size. So for example, I want to plot top 15 or top 10. So the default is 10. So you can change the size number when you call the function to change how many you want to see. So the same thing I did. So airport name and gender. I want to see the distribution of airports based on gender. And so you see, for example, with this Bathurst airport, we have more males traveling from there. But for example, Area airport, we have more females. So it just starts showing you this. So let me run this, for example. And if I change, for example, if I change this to 20, I'll be seeing the top plot for the top 20 airports. Okay, so size equals to size, yeah. So if you count, this is 20, so the number 20 is this, I can choose to do the same for the 30. So let's try 30. So we have more airports. It just shows, so you can change that. So that's a good thing about functions. You can really use them as you wish. Okay, I also want to see nationality based on, so the nationalities of the based on the gender. You can see that distribution. So already having ideas. So plot group bar. Okay, I wanted to see also top 10 nationality and flights. This in this case is the flight status. So which countries are, so because of the data is kind of evenly distributed, so we're not really seeing a lot of differences because the key is flight status. We want to know if it's flight status is delayed or cancelled. So if let me do top let's see top 15. Let's see how that differs. Okay, you see that distribution. Then okay, analyze departure date. So let's start looking at departure dates. So we've changed that. So you can, so initially we converted our departure date to date time. So we can now change we can now extract day, for example, the day they are traveling from the date status. So using that, you could see Sundays, how many people are, so you can see how many people, the date people are traveling the best. Okay, let's see, let's run this. So we also do use our plot group by the top 10 so you don't really, so for example, we have more travels on Sundays. Let's say we have more travels on Sundays, but people that travels on Fridays, you have high chance of cancellation based on the data. That's what that data is telling us. If you travel on Sunday, you have more possibility of your data of your flight to be on time. Let's see, if you're traveling Thursdays, okay, the probability of on time on Thursday is still more. But if you're going to travel Monday, Friday, there's every chance that you have higher percentage of cancellation and delays, and the possibility or probability of your flight being on time is less. If you're traveling on Tuesday, your flight is most likely to be delayed. And in other cases, if it's not delayed, it's either cancelled or it's on time. So with this, you can already see, for example, you want to travel using any of these airlines, you already have an idea of how the best day to fly to have the highest possibility of not cancelled, not non-cancellation or delayed flights. So the same thing we did here. Let's use departure month. Okay, so let's just copy this and use the same thing. So in this case, we want to extract the extraction month. So let's see the month with the highest. So August, people travel more in August. I think that relates to summer, for example. So let's just plot this same. Let's do the plot group bar. So you just call me a copy and let's plot the crop. So in this case, we're extracting month, for example. So I want to see distribution of the month. Let's do, so let's do 12 since we have 12 months. Okay, so for example, in this case, you can start doing your analysis. So if you're going to travel in January, one is January, so you have higher percentage of being delayed. So if you're traveling in March, you have more chances of March. March is 3rd, July is 7th. So within July and March, so that's October, that is the highest time you travel where you don't have cancellations. So let's start doing some time series analysis with our plots. So let's just go scroll down here. So in this case, I want to see the mean. For example, just get the mean of the data. So I want to see the mean amount of flights that were canceled. You can see, like for example, within in May 2022, we have a lot of reduction in flights in general. So there's a general reduction, but we have more reduction in on-time flights. So you have more delayed flights in around May. So in some cases, so generally from between July to September, I think that corresponds to summertime. You see a lot of the peak. You have more flights duration. You have more flights generally with in that case. Okay, so so this just shows you a time series data. See how things changes over time. See how the number of flights change over time. So this just shows you like line plots. I think you can really see, it just shows you the change in cancellation, departure date, how many. So it just counts how many flights. In this case, we just count the mean calculated the mean based on the month. This one we just did based on the day, so we have a lot of days, so that's why it's not. So you can choose to reduce your x-axis. You want to zoom into a particular region, a particular time frame. That would give you more spaces. So you can just check, okay, cancelled flights, how many cancelled flights you have based on the different things. So there are other time series analysis you can actually do using this data set. This is my simple, at least basic solutions for data analysis using the Airline data set. This notebook will be available in my GitHub, and I'll put a link in the description. If you really want to understand what I've done and follow through my notebook, just go there and follow through.